panelists and ask each of them to provide their perspective. A year ago, NFV was largely hype. I think most of you would agree that we were firmly in a hype cycle about a year ago at this event and in other events. If you look back on 2013, the number of NFV and SDN conferences that sprung up in the industry, it was kind of like LTE 3 or 4 years ago before that became real. So I'd like to ask our panelists to start with, what's changed in the last year in your discussions with service providers and other customers that made NFV and virtualization go from that hype stage to a real and meaningful discussion about how they're going to deploy it? What's changed?
So let's focus on the wireless aspects here from me. I'm sure Marcus will elaborate for the others. On the wireless side, what I see is that about a year ago, it was when you look at very black and white about the what's and the why, it was let's centralize everything to have the greatest performance ever. And frankly, some people are still beating that drum today. But what I see when we discuss with customers and other partners in the ecosystem is that the maturity of the conversation has changed. And specifically for that what and why, what I see is on the what side, instead of just looking at, well, centralization, what we see is there's a number of things that you can centralize, there's a number of things that you want to distribute, to Michelle's point as well. And that's specifically why we chose the virtual RAN or vRAN as the encompassing technology, but within that virtual RAN you have sub-technologies. Specifically, calling out one is the virtual BBU, VBBU, which is the level 2, level 3 type aspects, which we're doing together with Intel, which have very specific requirements. And in terms of pooling, in terms of memory bandwidth, in terms of everything you want to do with respect to scalability. But there's other aspects in virtual RAN as well, namely the performance assurance, the coordination for the parts which will not be centralized initially, because of course distributed RAN will stick around for quite some time. There's things like local functions of the EPC to improve VoLTE performance and local caching. So the watt size has significantly improved in maturity, and we now know exactly what that means for our products as well and which partners we need. On the Y side, it has evolved from performance as the one and only to performance for certain customers, for sure. I mean, we are present in the most performant networks in the world, and our code base that we use there will be directly used for the virtual BBU and virtual RAN as well. But next to performance, we have also operators focusing on the total cost of ownership, reduced lease cost, less equipment at the cell site, easier replacement of equipment, upgrades, and so on. That's the second. So performance, total cost of ownership. And thirdly, you have operators that are really focusing on the pooling and scaling aspects. The fact that you can add capacity where you need it, that you can scale the capacity when you need it, and that you can pool instead of having to dimension for the peak load, you can dimension from an average load and make sure that that goes all over your network. So that would be for me from the wireless side how the conversation has changed.
Thank you, Mark. Sandra, can you provide your perspective?
Well, very simply, I think everything has changed in a year. If any of you remember when the term network function virtualization was kicked off, it was in October of 2012, which was really not all that long ago. And to Lindsay's point, it seemed that a year ago everyone was getting on the bandwagon of NFV and the move to embrace standard-based server and virtualization into the network, integrate server and virtualization technologies, but also cloud-based business models. So here we are 1 year later, and many operators driving forward with what they believe is the compelling business need to transform their networks over time, to both be more operationally efficient, to better capitalization, lower total cost, but also to develop a platform for innovation of their networks in a way to monetize that core asset, that crown jewel, which is their network. There are almost 30 global service providers now participating in NFV in some way, shape, or form. We are moving from proof of concepts to trials and, in some cases, commercial deployments. And with the announcements here, market leaders like Alcatel-Lucent are indeed deploying commercial products and solutions. So what has changed? Everything has changed for the good.
Marcus?
Well, those are such good answers, I feel like I should just say what they said. I'll say a little bit more. I do agree that it's a combination of the conversation is now more intelligent, the technologies are now better, all the DPDK, SRIOV enhancements in Intel allow more to move onto that architecture and get the performance we're looking for. I think that the other thing though is the platforms that are available now, right? Because it's very easy to talk about putting an application on IA, but you need actually an orchestration and management system, which NFV has worked on, and Cloudband is our product, that actually allows that to happen and manages that application in a way that maintains carrier grade. It also does that distribution to distributed cloud, where there'll also be IA-based architectures, but you need something to manage that, so it replicates the performance of the box. Right, we break apart the box because that's a good thing to do, because it gives us elastic scaling, faster deployment times, ability to reuse capacity, all that's good, but I need something to recover the carrier grade attributes. So that's one. Secondly, the other platform that matters is the SDN piece, because I always say, a little bit facile, if I virtualize something but I didn't connect it to anything else, that's not very good, right? So in fact, by creating virtual machine instances, I need to connect them to each other. That's how I create applications, sort of the equivalent of the Web 2.0 mashup, but now I'm making applications by connecting together server blades. But then I need to connect it to the network again, because there is still that physical infrastructure. So the SDN piece as a platform, the virtualization platform, features in IA, and then a more intelligent conversation in the industry, I'd say, is what's changed.
Thank you. Questions from the floor? We'll start here, and then we'll go with Simon. So start here in the middle first.
Thank you. It's Didier Sama from Bank of America, Merrill Lynch. Just like to start with SDN and NFV, how you see competition coming from enterprise software like VMware coming into your space, how you see yourself going into their space as an opportunity, as a threat. Maybe just sort of if you could frame the debate a little bit around that. And then secondly, with regards to virtualizing RAM, obviously you are the aggressor relative to maybe your competitors in the RAM market. As you move the control plane to the cloud, what's the impact on RAM ASPs? How much of that is falling, and how do you recoup the loss on the hardware through software? And how much market share do you really need to get in those sort of functions to offset the pressure on the top line? Thank you.
Well, it's a very good question, but we could do half an hour on that one. I'll do the SDN piece. Fundamentally, SDN done right is actually a distributed router. So that's what a lot of people don't realize, that the way we built our SDN solution with Nuage is actually taking router code base, connecting into virtual switches that sit on the hypervisor sitting on IA, and then instead of having a switch fabric inside the router, it's the data center fabric. So really to win in SDN you need a routing code base. And so that's very important to realize that our movement into that space, which is your question, is premised on having a routing code base and not just premised on having a desire to be there. Routing code bases take 10 years to develop to have the robust feature set and performance you need. So for highly scalable multi-tenant clouds, there's no way you can be an SDN and be global scale, carrier grade, etc. without having a routing code base. So that's sort of our right to play in that space, and then all others are just pretenders. On the RAM piece, I think to my point about intelligent conversation, I'm not saying your question was not, but maybe I am. But my point is, it's not about ASPs, right? It's not about falling ASPs, it's about expanding capacity. That's really how the conversation changed in the course of the year, to get it out of this cost savings argument, which is sort of a declining momentum argument, because everyone wants to save costs. It's very poor motivator of big change. So I actually think the conversation now is about the elastic gain, and yes, there will be changes in ASPs because we're selling software, it's on someone else's hardware, etc. But that's not really the value proposition. We're saying, yeah, software is higher margin. Right? And then there are new opportunities, as Michelle explained, to sell that software into more market spaces, enterprises, web scale, etc., managing machines, Internet of Things. So it's hard to say, we've looked at this actually, it's hard to say whether it comes out as a net positive in revenue, flat, maybe a slight decline, but a higher margin. We're a bit unsure about, but we know we have to go there. And it's not a massive change in revenue. it might be up, it might be down, it might be neutral. From what we see, it's more about value gain in the industry where a rising tide floats all boats. But do one first for Sandra. By the way, I have to, before anyone asks a question, Sandra and I, with Philippe Carrier, actually worked on the deal together, and her perseverance, I have to acknowledge, in the face of obstinacy, corporate obstinacy. But it really was Sandra's doing so. Well done, Sandra. Yeah, lawyers, exactly. It's always the lawyers.
Simon, and then we'll take one for back next.
Thank you. Simon Leopold with Raymond James. I wanted to see if you could articulate the breaking point between merchant silicon and customized silicon, the use of ASICs in the business, help us understand where it's relevant and how that's evolving. And maybe Lindsay can chime in, since we think of the router portfolio with the FP3, and maybe if you could take this to competitiveness, because if everybody can buy the same merchant silicon you're buying, how do you stay ahead of your competition? Thanks.
Go ahead, you want to go first?
I'll just make a general comment. So I think Renee did touch on this a bit, which is that the idea is not to create custom solutions for Alcatel-Lucent. The idea is to leverage the Intel architecture franchise and the billions of dollars that go into not only microarchitecture innovation, but also process technology leadership. And from that perspective, as much as we can leverage from Intel architecture and our broad portfolio from Atom Fork up through Xeon, we're going to do that. Now, having said that, we clearly understand that our customers need to differentiate. But how much that differentiation happens in hardware versus software over time, how much happens in terms of integration capability, in terms of services capability over time, and then of course, how much happens simply by being first and fastest. That's really, the market will be the arbiter of who will earn and win the business. From our perspective, we will continue to invest in server technology, in virtualization technology, in security elements, which we know as we move to the cloud, that is the biggest inhibitor, the biggest concern for anyone moving to cloud. But over time, we do believe that we will be able to out-invest and out-innovate our competition and provide that foundation for differentiation for our customers.
So I know you want numbers from me, and then Lindsay will have his number, because it really is, anyone could have their own number. The number we have today, although I'll explain that, we've already explained the DSP part, right? So anything that's done sort of, that's doing analog, let's put it that way. DSPs basically do digital analog in some fancy way, right? So anything that's launching analog will stay in a dedicated component. So you can look at those boxes and say, that one for now stays in a dedicated component. Then when we talk about high performance packet processing on sort of core router level, that stays in a dedicated ASIC. So where is the line on that one? That's really the question, I think. The line we think is somewhere around 100G today, meaning 10G clearly has done well on IA. I think everyone accepts IA can support sort of 10 gigabit packet processing on a single core. So 100 gig starts being the demarcation where we think there's a transition, but that line moves, right? And it depends on the application a little bit. So I'll put 100 gig just because it's an easy number. And 400 gig we think solidly is on the side of ASIC. But that's where our number is today, but it shifts over time, as Sandra said. So next, 5 years from now, I'm sure Intel will be doing 100 gig well, but then the silicon will be doing Tera. Okay, but Lindsay.
Yeah, I mean, I'd answer the question in a different way. In that, if you think about, we've talked about here today and in the last few days about virtual EPC, and we're showing it on our booth and we're demonstrating it with China Mobile on their booth. Virtual EPC doesn't replace physical EPC, it augments it. It provides for the environment where you want dynamic scaling, possibly driven by machine-to-machine environments. So where you want to offer a service that needs dynamic scaling of control plane, up and down, many millions of short-lived flows, low volumes of traffic but high volumes of signaling. Virtualization makes perfect sense today. But it doesn't replace the real EPC where you're dealing with very high volumes of, say, video traffic that are consumer-driven. So think of it in that way particularly. I mean, our sense is that the things that will get virtualized first are the layer 4 through 7 applications that have been running on ATCA in the last few years. Those are very obvious to move rapidly to a true cloud-based virtualized architecture. And as Marcus was saying, the lower level of higher performance stuff is somewhere down the road, if at all.
And the thing about ATCA was an Intel architecture just on telco boxes.
Yeah.
So there's no surprise that we're adding a virtualization layer. Why? Because it allows us to move the stuff around and do all that great stuff and simplify the onboarding. So it should be obvious on that.
Maybe add a little bit to Marcus's point from a purely wireless perspective. I mean, it's important to distinguish between what you can do today versus what you should do today. So while probably, and there are people working on putting everything on GPP today, for us it's most important as being the aggressor, and I actually like that term, to have the best of breed, which means that for the layer 2, layer 3, we know we can and should do it today on Intel. For the other aspects, we're partnering with those companies that provide to us what we think is the best of breed, while of course together with Bell Labs looking at how can we migrate and make that offer maybe even more homogeneous in the future.
Thanks for the plug for Bell Labs.
Do we kiss as well? And then there was a question here next. So a question at the back, and then next.
Hi guys, it's Brian Partridge from Yankee Group. My question is about driving this forward. So we've seen big brands coming together like this, and there's some challenges both in terms of what the customer is going to, there's challenges in front of the customer, but also challenges within your own organizations to motivate behavior. So first of all, I'm wondering, are you guys already agreed to what constitutes success in this partnership in terms of managing it from your side? And then in terms of the customer, what should we expect in terms of what the customer, how the customer will be engaged? Is ALU to lead the engagement with Intel at its side? Does Intel lead some of these engagements? So what is that going to look like?
Go ahead.
So for us, success is measured in market acceleration. So we certainly have an objective to get to market faster, given this upside-down business problem that the carriers face in, not months, but also not many years away. From that perspective, a lot of the collaboration focus is really how do we optimize, how do we get highest performance, and how do we get out there quickest in the market. From the service provider perspective, they're looking for two things. They are clearly looking to save money and have a better TCO equation, but you're not going to save yourself out of the problem that they've got. What they're really looking for is to develop a platform of innovation, as I mentioned earlier, to be able to monetize that core asset, the network. And what you'll see even here at Mobile World Congress, but what's been happening over the past 15 months in earnest, is moving from those technical feasibility studies, the lab proof of concepts to actual trials and deployments. You'll hear that from China Mobile this week, you'll hear that from SK Telecom, you'll hear that from Telefonica. But beyond that, I think that that from a success equation, it is really to be able to enable broad participation and have the market leaders out in front really addressing their customers' requirements faster.
Yeah, I've been surprised at how much resonance there's been on the three areas broadly EPC, the cloud platform, and virtual RAN. In each case, it's because the teams both see the benefit of the other's perspective. So Intel's been working a lot on the data plane optimization elements, can help with sort of latency requirements of software that we need, adding more and more features into IA. Frankly, us getting a preview and it's some input into what those features are. And you're right, we've been working on dedicated silicon for some of those functions, right? So we actually know how we optimized, say, a network processor. We know how we optimized in some cases on a MIPS processor. So we know exactly what we had to do there, and we're able to sort of collaborate and say this is the best way to go forward to get the performance we want to see on IA, and then we learn how IA really works, that helps us write our software a little bit more efficiently. So it's really been a resonant interaction there. But it's not exclusive, and the idea is to put that back out in the marketplace. That's actually key. The generic innovations will go back out into the ecosystem. And then obviously we'll do some specific things in our software that we think will give us performance advantage. But mainly this is about first mover advantage, not doing proprietary things. And it's about higher performance because we worked on a design together, so that design is largely available sort of in the open ecosystem. And we just have a first mover, perhaps an optimized piece of software because we knew what was coming. So think of it that way. There's a very strong resonance between the three teams. Would you agree?
Yeah, I think you asked Brian as well about the go-to-market side and engagement with customers. I think our partnership is very much focused on R&D innovation together and optimization of Alcatel-Lucent's network functions on IA. In terms of customer engagement, we'll keep doing what we've been doing, which is Intel will work directly with customers, we'll work directly with customers. It'll all just work better now.
Yeah, it's not a go-to-market.
It's not a go-to-market sales, who engages, which accounts type of partnership. It's very much focused on the R&D and innovation side.
One of the things I'll say, which has been sort of interesting in the last 6 months, we're actually not making the decision on what gets deployed in data center. Right? So we're not saying you have to deploy on a certain server blade architecture, because our whole premise at Alcatel-Lucent is deploying whatever is there. So it's the whole idea of recreating carrier grade on commercial compute. And it just so happens Intel is commercial compute. Right? And so my point being is we're not trying to do anything that is proprietary on any specific platform. We say whatever is in your cloud, and it happens to be IA, we'll leverage that and we'll leverage it as best we possibly can to get the performance you want. So there's no go-to-market in that, right? Because essentially we're not the ones really selling the infrastructure. It's just we'll say we can use that particularly well.
Great. One more question there, and then we'll have one last question after this one.
Thanks. Loud. Hi, Lindsay. It's Ehud from Citigroup. So going back to an earlier question about exclusivity, that Renee, or actually I think Michelle answered more than Renee, but I'm interested in Sandra's point of view, and then there's a follow-up to that. Is this exclusive to the other side? Because it sounds as though you've been working, Intel's been working closely with Alcatel-Lucent for some time, which is why you have actual trials and real customers and real product. But have you been working with Alcatel-Lucent's other competitors, both in Europe as well as in Asia, on similar types of products? And as we go to NFE, Alcatel-Lucent will have 100% share, so there are other guys out there who are also working. So I want to know, I'm interested in understanding who else, you don't have to mention names, but are you as engaged with other customers, as other infrastructure providers as well? And how mixy and matchy can you get once you get to an all-software virtualized world? Take the virtual RAN, for example. Now, historically, it's been that Alcatel-Lucent sells a chassis, sells a base station, and then it has exclusive right to essentially fill that chassis up with ALU blades going forward, whether they be 2G, 3G, 4G, whatever. Are we looking at a situation down the road as we get to this NFV architecture where Alcatel-Lucent sells a chassis, but in fact, because the blades are now software blades, so to speak, and they're all based on standardized Intel Xeon processors, that perhaps it could be filled up with competitors, that the chassis could be filled up with quote-unquote software blades of competitors, and the same thing for EPC, et cetera. So if you can address those two issues, I'd just be curious to see how that evolves. And Marcus,
I'll address the
how we're going to sell
product,
software.
the product portfolio question. But I will answer the question, and I think Renee did touch on it, as did Michelle, which is there is nothing exclusive in the world that we live in, really, in terms of either Alcatel-Lucent's ability to land their differentiated software capabilities on other silicon architectures, or Intel architecture enabling a number of other market leaders in the industry. And indeed, we are working with every major market maker in the world of network infrastructure, leveraging from our strength and leadership position in all things IT, data center, cloud. We think this is good. I think Marcus termed it well, all boats rise, because this indeed is addressing the service provider challenge and opportunity. And you will see many announcements, in fact, at Mobile World Congress about NFV portfolio and NFV products based on Intel architecture. We will continue to, as I mentioned earlier, invest and innovate. We believe that, like everyone else, we have to earn every design and win every piece of business. And we are very confident that we will continue to lead and earn Alcatel-Lucent and other market leaders.
On the second part of your question about could other software be deployed on those nodes, for sure that's the case. Right? Otherwise we'd sort of failed. We've recreated boxes. They just, instead of the blades being vertical, we put them horizontal and we put a top of rack switch. That really wasn't very clever. So the idea is indeed that we can deploy in a flexible way on any infrastructure. That node could have been someone else's node that was previously deployed for a function, and we leverage our software on that node, and likewise the reverse is true. And if you think about it, Cloudband is already onboarding applications that aren't just Alcatel-Lucent. Nuage is already controlling or performing SDN on data center switches that are not Alcatel-Lucent. It's just a software release, right? And so those two things are premised, which, as Michelle indicated, sort of the foundation of all this is sort of an NFV platform, an SDN platform, and then our virtual applications. And they're meant to be just competing on their own merits in the market and not creating artificial bundles and proprietary solutions. Of course, we will attempt to get better performance out of a set of things we own, but it'll essentially be each one of those will in principle be replaceable by someone else's equivalent function. You're beginning to see little companies coming up with EPCs, right, for M2M or for whatever. These players will exist in the space and might couple to our larger scale EPC, and they have a special purpose EPC. That sort of model is entirely likely. I think where we'll win is on scale and performance, but it may not be that we win on only scale or only performance for different segments of the market, right? It's a combination of scale and performance. I think we're always going to win. I think we will. But low performance, low scale, maybe someone else has a solution that should be playing in that market and we'll couple into using the SDN or NFV framework.
One specifically for the wireless part, I mean, everything about this session is of course about virtual RAN. We shouldn't forget that there's still some part which is out in the field as well, that is coupled to that virtual RAN, namely the radio heads. What we're doing with certain US providers is making sure we have the best, most wideband radio head possible. What we're doing in the TDD space is making sure we have the best, most performant 8x8, for example, radio head. That's one aspect, and you shouldn't forget that and how that couples to that virtual RAN is important as well. Second part is, and that's where the Intel partnership comes in, while you have the IT cloud with very specific requirements, we know already today that the centralized architecture, the cloud that requires hard real time, that we need today, that we have today for our 3G RNC, that we're building on for our LTE, that ecosystem and those requirements still need to be built. And that's where we believe we will also have a unique capability through these interactions to have, as Marcus says, a better performance software, although the hardware base might be homogeneous across vendors.
Yeah, I think just to echo what Michael said there in a nutshell, I think in many parts of the network, hardware differentiation will still absolutely be critical. Particularly in the radio side of things, as well as in the layer 0, layer 1 infrastructure piece. And then where pure virtualization, where the application of the network function is virtualized fully, software differentiation is going to become increasingly important. And release 1 will never have as many features as release 2, which will never have as many features as release 3. And so the maturity of your software base and the feature capability of your software base in areas like IMS, in areas like EPC, is going to matter. And that's where we think we're very strong as well. So one final question.
Lador's desperate. He's been so it was so polite as well. He's going to storm the stage like some of our competitors.
Tiny
Okay, I'll let Lador take my
I'm just sitting on the side and I'm hearing the same question repeated. I just want to give a bit of a perspective, which is, if you're not exclusive to each other, what are you announcing? That's kind of what I'm sensing, right? Is this just a marketing photo op type of thing? And it's not. And I know Intel works with our competitors, and we have to do our diligence as well. But I think what's unique, and we've been working together for a while in this part of the relationship, is taking it to the next level to achieve acceleration in the industry. And NFV right now is no longer about the technological feasibility. The stuff works on IA. Okay, it just does. There are lots of tricks to increase performance, but to get NFV adopted in the field, it's about getting through the operational hurdles. How can applications consume DPDK and SRIOV and other Intel technologies simply, without going into the code and making changes? How can we get customers comfortable around the change? Whether it's finding root cause, whether it's dealing with multi-tenancy of applications, whether it's dealing and managing distributed clouds. And we're going to do a lot of work together there, whether it's joint experimentation with customers, taking the insight we find in the field and hopefully delivering it back to Intel to drive next generation products, and whether it's experimenting and seeing which of the Intel tools, together with other best practices, can get us the performance we need. So it's not just photo